Hello Devananda, JNV Haveri. I've been waiting for you guys. Where are you? Where are you all? So, good evening, everyone. I hope that all of you are doing good and being great in the physical state and mental state. So, here we are with the Enable Plus calorimetry and heat transfer. And I think you have been studied with thermodynamics and the basic laws related to thermo. And in the previous session, I think you have learned about the thermal expansion and thermal properties of metal. Now, in this class, we will be discussing about a bit about this calorimetry, what is it, and then basically our main agenda is to discuss about heat transfer here. Okay, so hope that all of you will join on time so that we will have at least 50 minutes to solve questions and all, delivering the concept to you. Got it? So make sure that I am audible to you and the screen is visible. So firstly, let me know if the screen is visible and I'm audible to you. Everyone, let me know in the chat box. Okay. So only one student has responses. That is Dimple. Devananda, Dimple, Farnaz, ITZ, Shami, JNV, Haveri. Am I audible to all of you? Is the screen visible to you? Let me know in the chat box. So today's learning objective is calorimetry, conduction, convection, radiation, and Newton laws of cooling. Got it? So firstly, we will describe that. Thank you, Devananda, for confirmation. Thank you, Farnaz. Now, calorimetry is the different segment and conduction, convection, radius. These three are in the unit of heat transfer. Heat transfer. Okay. This is all also involve this Newton laws of cooling. So we will be dealing with more laws and statements and deriving them and look at the behavior of the heat transfer and why we need it first of all. Okay. So firstly, we will start with calorimetry. When you start with the calorimetry, you need to understand what the isolated system is. Although when you have studied about the thermodynamics, the very first chapter that you have learned about it, that what is an isolated system and types of system, open system, isolated system, and closed system. Okay, a system is said to be isolated if no exchange of or transfer of heat occurs between the system and its surrounding. So suppose I have decided that this system will not exchange the heat and not transfer the heat, which means we cannot add the heat to the system or we cannot transfer the heat out of the system. Okay, so that particular system is termed out as what? Isolated system. ठीक है, जैसे थर्मो स्टील का बना हुआ थर्मल फ्लास्क. ठीक है, दिस इज अ थर्मस. सो इस थर्मस में भी क्या होता है? वी पोर द हॉट लिक्विड, इट रिमेन्स होल्ड, इट रिमेन्स हॉट up to some extent of time, है ना? So which means at up to that particular instant of time, as long the water or the liquid that you have poured in it remains hot or remains as it is as you have poured it, so that time this thermos is acting as a isolated system. Okay, this is the one of the example. Now what is calorimetry? Calorimetry is based on the measurement of heat. देखो, we measure the heat in terms of calorie, and this is calorie plus metry, which means measurement of the calorie, and calorie we measure in terms of heat. So calorimetry means the measurement of heat, how to measure the heat, and basically the heat transfer we are talking about. ठीक है. Now when a higher temperature, अब देखो heat transfer कब होता है? Whenever the heat transfer happens. Heat transfer happens when there is a difference in the temperature. ठीक है. Whenever there is a difference in the temperature, heat will flow from higher temperature to lower temperature. Got it? Now, the principle of calorimetry says that whatever the heat lost by the hot body, it's same as if all the environmental condition is same, that will be equal to heat gained by the colder body. Okay. For example, let's say this is a cold body and this is the hot body. Now we have attached this hot body to the cold body. Now transfer of heat will take place from hotter body to the colder body. ठीक है. Until and unless they will both have the same temperature. ये heat transfer कब तक होगा? Heat transfer will take place till the temperature became constant. Okay. Suppose this hot body have a temperature of T1, this cold body has a temperature of T2. When we know that temperature T1 will decrease because it is losing the heat, and T2 will increase. Suppose there is a lose in the temperature, here is delta T, so same will be the gain. Now in terms of heat, if you will see, let's say Q, delta Q amount of calorie of heat this hot body has released. So if environmental is strictly bound, which means this is an isolated system, so heat can only transfer from hot body to the colder body if we neglect the heat transfer to the surrounding. So whatever the heat transfer here is will be heat gained by the cold body, isn't it? So if we lose, let's say 100 joule of heat or 100 calorie of heat, 100 calorie of heat will be gained by the cold body. This is the principle of calorimeter. Simple. Now, what is a calorimeter? अब कैलोरीमीटर से कहाँ से आया कैलोरीमीटर? कैलोरीमीटर is coming from the measurement of it. So it is a device which can measure the heat. ठीक है? That is calorimeter. Although this is not like so much of required, but you can see here, this is a circuit here, and we have a resistance. ठीक है? When the current flow, there will be heat loss in the resistor. So the heat is provided to this particular liquid. This is the stirrer to mix the heat well, and there is a thermometer also. ठीक है. So whenever the heat will be released, this stirrer moves so that the heat will be, whatever the heat given by this resistor will be distributed equally among the liquid, and then we will measure the change in temperature of the liquid. ठीक है. This is a metallic vessel. आउटर जैकेट एक्ट एज अ हीट शील्ड, मतलब यहाँ से हीट शील्ड की तरह एक्ट करेगा, which means no heat transfer can take place within the walls of the calorimeter. ठीक है. And reduces the heat loss from inner vessel. Clear हुआ? ये insulating material है, and this is wooden jacket. अब देखो, specific heat capacity of a given substance can be determined by the using the principle. Specific heat capacity क्या होता है? So I think you are well aware about it. It is the heat required to raise the temperature of unit mass by unit degree Celsius. ठीक है, to raise the temperature by unit, ठीक है, of unit mass, that is the specific heat capacity. ठीक है, that is termed out the specific heat capacity, which means heat given by the resistor is equals to heat gained by the water. So that is the principle of calorimetry. Now heat given by the resistor is the power loss here, which is nothing but I into amount of current multiplied by voltage, which is equals to heat gained by water. So water कितनी heat gain करेगा? ms into delta T. ठीक है. Now heat lost by the water plus heat lost by the calorimeter. अगर मैंने यहाँ पे आइस पुट कर दी, अभी अभी मैंने पिछले केस में क्या किया, इस वाटर को वार्म किया, गर्म किया, उसके बाद विद द हेल्प ऑफ दिस रेसिस्टर, उसके बाद आई हैव poured some amount of ice into it. Now this ice would melt because the temperature of the surrounding is higher. So heat will be lost by the water because this water transfer heat to the ice, plus heat lost by the calorimeter if there is a calorimeter attached, equals to heat gained by the ice to melt. Okay. Now based on this you can solve this question. Try to solve it down. The temperature of 50 gram of water has to be risen from 15 degrees Celsius to 85 degrees Celsius using a steam at 120 degrees Celsius. What is the amount of steam in gram required for the same? Now here the specific heat of the water is given, 1 calorie per gram degree Celsius. Latent heat of vaporization is also given, 540 calorie per gram. And S is here the specific heat of steam, which is 0.48 calorie per gram. ठीक है, क्लियर है आपको? अभी देखो, what is a latent heat? First of all, we will describe that. How many of you know about the latent heat? Let me know in the chat box. It is the amount of heat required to change the phase of a substance. ठीक है, no one will know about this latent heat. Devanand, ABD, Azmala, Dimple, Satya, Suhara, Sanmukhi, फरनाज, एवरीवन. देखो अभी क्या होता है, जब सॉलिड लिक्विड मेल्ट करेगा, we know that there are three states of matter. The first one is solid, then liquid, and then gas. Got it? Now if I take the example of water, in the solid state it will be ice, in the liquid state it will be water itself, and then the gas stream it will be steam. ठीक है. Now when we raise the temperature of gas ice, it start melting and it will become water. When we raise the temperature of water, it will not initially started rapidly start boiling. After a certain point of time, after a certain point of time or certain point of temperature, this will start boiling. ठीक है. So water boils as let's say 100 degrees Celsius पे boil करता है water. After that, if you transfer more heat, the temperature of the system will not reach. ठीक है. But where this heat is going, we are constantly providing the heat to the system, heat to the water. So where is this heat is going? So that heat is nothing but latent heat. Latent का मतलब ही होता है hidden. ठीक है. This heat after the boiling point, achievement of the boiling point, This heat is utilizing the change of state from water to steam. ठीक है. Similarly, when you raise up the temperature of ice, it will not melt initially, but it will absorb heat. Temperature will be rising up. But at 0 degrees Celsius, this will start melting. And if you further give it heat, the temperature of the ice will not increase above 1 degree Celsius. Sorry, above 0 degrees Celsius. So where this heat is going? This heat is going to melt the water in melting, which means the heat that is required to change the phase of a substance from solid to liquid, liquid to gas. That heat is nothing but the latent heat. अब देखो, water से gas जब बनेगा तो we will know that it will vaporize. So here the heat is termed as latent heat of vaporization. ठीक है, वही यहाँ पे गिवन है, देख, latent heat of vaporization, which means 540 calorie per gram is the heat that is required to change the phase from liquid to steam. Now this has a formula, Q is equals to M into L. Simple formula. ठीक है, you can note down this question, you can try it by your own, and then let me know the answer. In the next class we will be discussing more and more questions. ठीक है. Now, so here, if you will try to solve it, it will simple. Heat gain, heat gain is equals to heat loss. ठीक है. अब हीट गेन कौन करेगा? देखो, टेम्परेचर ऑफ 50 ग्राम ऑफ वाटर हैज टू बी रिजन. इतना रेज करना है 50 to 85 यूजिंग ए स्टीम और 120 डिग्री सेल्सियस. तो स्टीम को अगर मैं वाटर पे पास कर रहा हूँ, तो स्टीम विल like lose the heat here, because steam is at 120 degrees Celsius and water is initially at 15 degrees Celsius. It is given. ठीक है. So heat gain is by the water, and that heat gain will be nothing but M into S into delta T, or you can say MC delta T. ठीक है. S क्या है? Specific heat है. Specific heat of water is given to you. Amount of water is also given to you. Now, heat loss is by the steam. तो इसके लिए भी again Q for steam will be M S of steam into delta T. Temperature difference is also given to you. But जैसे जैसे steam ठंडा होगा, it will what? It will again converting back to liquid, isn't it? So वहां पे latent heat of vaporization का यूज होगा. Q is equals to M into L. ठीक है, क्लियर हुआ? Now, now we will starting the chapter which is heat transfer. Heat transfer. हीट ट्रांसफर का फर्स्ट वे है इज टू कंडक्शन, कन्वेक्शन एंड रेडिएशन. ठीक है. अब हीट ट्रांसफर क्या है? ट्रांसफर ऑफ हीट फ्रॉम वन सिस्टम टू अनदर बिकॉज ऑफ द टेम्परेचर डिफरेंस इज नोन एज हीट ट्रांसफर. ठीक है. दिस इज अ वेरी सिंपल डेफिनेशन वी कैन एक्वायर. Now there are three types of mode of heat transfer. You can transfer the heat using three modes. The first one here is conduction, second one here is convection, and the third one is radiation. Okay. Now, what is conduction, convection, and radiation? We will be elaborating it one by one. Now, firstly, we will be seeing this figure. What do you see here? Now, it's very familiar in nowadays to burn the woods or to like keeping the hands warm. We usually burn the heat in our houses using woods and some like leaves and all. Okay. So at that point of time you do not need to put your hand into that heat to get it warm. If you take this is away, slightly away, if you keep your hand slightly away from it, then also it will keep you warm. Okay, but if you put a metal rod into it, and we usually do so, we use at this type of device to catch up the heat elements there, coal basically. So what we find out that after some time this will become hotter. And why? Because it is making the direct contact with it. The temperature of this end will rise in so rapidly, and that will be transferred to this part because this part has lesser temperature. So heat will be transferred from higher temperature to lower temperature. Now, without contacting, what is the source that is providing the heat to us? That is nothing but radiation. Okay, and the warm gases, if you just place your hand slightly directly above the where the heat is going on, at that point you will find that the air is also getting hotter and hotter, and that mode of heat transfer is convection. Now, firstly, we will elaborating conduction. What is conduction? So conduction is the mechanism to transfer heat with the direct contact. ठीक है, तो ये कब होगा? When you acquire the mode of heat transfer, that is conduction, is basically the transfer of heat taking place within the contact. Okay, and this is happens usually for solids. So when you take the proper contact with each other, then you, if you're transferring heat by making two system contacting with each other, that mode of heat transfer is conduction. So conduction is the mechanism to transfer heat between two adjacent part of a body because of their temperature difference. So this is the direct mode of heat transfer. इसे हम डायरेक्ट मोड ऑफ हीट ट्रांसफर भी बोल सकते हैं, डायरेक्ट मोड ऑफ हीट ट्रांसफर. Okay, now like this, suppose you want to cook Maggie, 2 minute instant noodle you want to make, and you put the pan above the burner, but you forgot to put some water or something else in it, and you just directly touch it, and if it is metal, completely metal, then you will find out that it is getting very hot. Why it is so? Because this is in the direct contact with the heat, so heat transfer is taking place at this part which is in the direct contact, and then transfer it to the other part of the system. Okay, because the temperature of this end will be lower and the temperature of this end will be higher. So higher temperature से lower temperature की तरफ heat transfer will take place. So that mode of heat transfer in which direct contact is required is known as conduction. ठीक है, but the one point to remember here, that is you can make it underline, that heat transfer in conduction happens without transferring the material of the part. ठीक है, मतलब क्या होगा इसका कि इफ यू रेज द टेम्परेचर ऑफ दिस पेन, ऐसा तो नहीं है कि पेन की ये मेटल यहाँ पे आ जाएगी, ये मेटल फ्लो करेगा यहाँ पे इसे टेम्परेचर रेज करने के लिए इस एंड का, नहीं ना. सो व्हेन द मटेरियल is not required to flow from one point to another point to transfer the heat, that mode also is termed as the conduction. ठीक है, so material, without transferring the material particle, it happens. Now most of you are wondering that, okay, so it can be transferred with the transfer of material also. Yes, and that mode of heat transfer is convection. ठीक है, अब देखो यहाँ पे हमने क्या किया, दिस इज द कैंडल हियर. सो या धीरे धीरे ये क्या कर रहा है, temperature with the adjacent air is increasing and this is transferring. But if you notice here that this particle is not moving at this point or this point or this point, which means without the material transfer, the heat conduction will take place. ठीक है? Now, let's just derive the expression for heat conduction, rate of heat conduction. Suppose these are two blocks, Tc and Td are the temperature. Tc is the temperature which is greater than the Td. Okay. Now, we have attached a metal rod to it. The cross-sectional area of A, which is and having a length L. So it is directly connecting this red cube to this blue cube. Okay. And on the above side of it, we have provided a coating so that heat that will be transferring will not lose in the surrounding. तो वो क्या हो surrounding में loss ना हो उसका. That is why we are using this insulation here. Now, according to the experiments, after some time the temperature of both the body will acquire an equilibrium condition. Okay. So experimentally it is find out that the rate of heat flow is directly proportional to what is the temperature difference in between them. Secondly, what is the area of cross section? This is this. Okay. Area of contact, which is this, because by this area of contact we are transferring the heat from one place to another. Okay. Now, inversely proportional to the length. अब देखो ये बहुत ज्यादा क्लियर है कि if I take a length like this, ठीक है, और मेरे पास दो ब्लॉक है जो डिफरेंट डिफरेंट टेम्परेचर पर, एंड इफ आई टेक अ रोड लाइक ठीक है, दिस वन, दिस वन, सो यहां से यहाँ हीट ट्रांसफर में ज्यादा टाइम लगे, एंड मे बी ऐसा हो सकता है कि जब तक ये वाली हीट यहाँ पहुंचे तो ये वाला एंड क्या हो चुका हो, ठंडा हो चुका हो या लॉस हो चुका हो कुछ ना कुछ. सो एज वी इंक्रीज द लेंथ द हीट विल डिक्रीज, सो दैट इज व्हाई इट इज इनवर्सली प्रोपोर्शनल टू द लेंथ ऑफ इट, एंड इट इज डायरेक्टली प्रोपोर्शनल टू द एरिया ऑफ क्रॉस सेक्शन, क्योंकि जितना ज्यादा एरिया ऑफ क्रॉस सेक्शन कॉन्टेक्ट में होगा उतना ज्यादा हीट ट्रांसफर के लिए सरफेस ओपन हो. ठीक है. इफ आई टेक अ बिगर रोड or bigger metal, so to transfer the heat, definitely the rate of heat transfer will increase because now the contact area is more. ठीक है. So to remove this proportionality sign, we use a constant here which is nothing but k. ठीक है. Now h is directly proportional to a into tc minus td by l. अब यहाँ से to remove this proportionality sign, we use a constant k. तो h इज इक्वल टू k इंटू ए टी सी माइनस टी डी अपॉन एल. अब ये k क्या होता है यहाँ पे बताओ. where k is called the thermal conductivity of the material, which directly depends on the type of material that we are using. ठीक है. SI unit of k is joule per second per meter per Kelvin, और joule per second को we can write as what, which is nothing but power. So power here is sorry, this k is nothing but watt per meter Kelvin. Okay. क्लियर है. जितनी ज्यादा के की वैल्यू होगी उतना ज्यादा मटेरियल क्या होगा, कंडक्टिंग होगा. ठीक है. सो फॉर नॉन कंडक्टर मटेरियल के लिए द वैल्यू ऑफ के विल बी वेरी वेरी लेस, है ना, तभी तो उनका हीट ट्रांसफर रेट क्या होगा, बहुत ज्यादा कम होगा. बट इफ द वैल्यू ऑफ के इज वेरी वेरी हाई, व्हिच मींस दैट पर्टिकुलर मटेरियल इज पोजेसिंग अ वेरी हाई रैपिड रेट टू ट्रांसफर द हीट, दैट इज व्हाई इट विल बिहेव एज अ गुड कंडक्टर्स. ठीक है. नाउ if you talk about it in the differential form, in the differential form, or when you say when the area is not constant or length is not constant, in that case heat transfer will be given by dH is equals to k a dt by dx. Okay. when heat transfer is not constant. ठीक है, and this is for the steady state. Okay. अब steady state में और थर्मल इक्विलिब्रियम में डिफरेंस होता है, पहले मैं वही बता देता हूँ आपको. डिफरेंस इन थर्मल इक्विलिब्रियम एंड स्टेडी स्टेट. देखो स्टेडी स्टेट का मतलब है व्हेन टेम्परेचर, बिकॉज टेम्परेचर इज द ओनली ट्रांसफरेबल वैल्यू देयर. टेम्परेचर, क्योंकि रेट ऑफ हीट ट्रांसफर वी आर डिनोटिंग बाय द टेम्परेचर डिफरेंस. सो व्हेन टेम्परेचर ऑफ द सिस्टम, or we say that rate of heat transfer is independent of time. When the rate of heat transfer is independent of time. ठीक है, that is the thermal, sorry, that is the steady state. इसे क्या बोलते हैं हम, स्टेडी स्टेट. बट इसका मतलब ये नहीं कि टेम्परेचर से सेम होगा. ये मेरे पास एक सिलेंडर है, लेट से मटेरियल का, कंडक्टिंग मटेरियल का. अगर ये स्टेडी स्टेट में है तो जो टेम्परेचर है वो टाइम डिपेंडेंसी पे नहीं होगा. बट इफ यू से एट अ डिफरेंट लोकेशन, लेट से x1, x2, x3, x4, सो हर पॉइंट पे मेरा टेम्परेचर क्या होगा, डिफरेंट होगा. सो टेम्परेचर विल वेरीज विद द पोजिशन, नॉट विद द टाइम. सो दैट स्टेट इज स्टेडी स्टेट. एंड थर्मल इक्विलिब्रियम में क्या होगा, थर्मल इक्विलिब्रियम में ना तो टाइम के साथ टेम्परेचर बदलेगा और ना ही पोजीशन के साथ. सो एट डिफरेंट पॉइंट टेम्परेचर इज सेम. So that state is thermal equilibrium state. ठीक है, when temperature is not the function of position and, but here you can say temperature is the position of या function of x. ठीक है. Now what is thermal resistance? थर्मल रेसिस्टेंस को अंडरस्टैंड करते हैं. यहां से मेरे पास इक्वेशन बनी थी that rate of heat transfer, which is h, nothing but dq by dt, is equals to ka dt by dx. ठीक है, एंड इट विल बी नेगेटिव ऑलवेज बिकॉज रेट हीट ट्रांसफर क्या होगा, नेगेटिव, हायर टेम्परेचर से लोअर टेम्परेचर तक. ठीक है. नाउ in the steady state we can say h is equals to minus, or if we remove this minus it will be ka delta t by l, isn't it? So h here is nothing but ka upon l into delta t. अब देखो ये डेल्टा टी क्या है, this delta t is the driving force, isn't it? The driving force. Due to this change in temperature, this heat transfer is taking place. ठीक है, so this is the driving factor or the driving force. ठीक है, if you can this is the rate of heat transfer, which means dq by dt. So if you compare it with Ohm's law, that is nothing but, for now you can relate it. Ohm's law आपने 10th क्लास में पढ़ा होगा, v is equals to I into r, और we can say v is equals to ri. v क्या होता है, डिफरेंस इन पोटेंशियल, एंड I is the rate of change of और रेट ऑफ फ्लो ऑफ चार्ज. ये यहाँ पे h क्या है, रेट ऑफ फ्लो ऑफ हीट dq by dt, which means I represents h here. ठीक है, I can be replicate with h. This delta t is the driving factor. Here the potential difference is the driving factor. So delta t will be the same thing. So we can say that delta t is equals to L upon K into H. This replicates V. This replicates I. ये heat current है, that is I. तो ये क्या हुआ? This replicate resistance. So here R will be nothing but L upon K into A, which is nothing but the thermal equilibrium, thermal resistance. ठीक है, thermal resistance will be given by L upon K. Now if the system are in series, अब देखो सीरीज में कैसे, ये मेरे पास एक रोड है, इसके साथ एक दूसरी रोड जुड़ी है, ऐसे when the one end of the road is connected to the another end of the road. So this type of condition you can replicate it like this, R1 and R2. Let's say the length of this road is L1, area is A1, area of cross section, and thermal conductivity is K1. For this road, it this same L2, A2, and K2. So R equivalent will be given by R1 plus R2. तो यहाँ पे आप थर्मल equivalent is given by RT1 plus RT. अब RT1 क्या है? L1 upon K1 A1 plus L2 upon K2 A2 plus ups to n. मतलब जितनी ज्यादा रोड आप देखोगे कि पैरेलल सीरीज कनेक्शन में है, दैट विल बी गिवन बाय दिस. ठीक है, नाउ फॉर पैरेलल कनेक्शन, और पैरेलल कनेक्शन कैसा होगा? लाइक दीज आर द रोड्स कनेक्टेड इन दिस मैन. एक बॉडी से दूसरी बॉडी में, यहाँ से टी एच हाइयर टेम्परेचर और यहाँ पे टी एल. ठीक है, तो रेट ऑफ हीट ट्रांसफर इज डूइंग लाइक दिस when the same end of the road are connected with each other. So in that case, 1 upon R thermal या 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. ठीक है, सीरीज कनेक्शन में हीट ट्रांसफर का रेट क्या होगा? सेम होगा. क्लियर है? नाउ thermal conductivity of different material is given in this. सिल्वर, कॉपर और एल्यूमिनियम विच आर द मेटल्स की थर्मल कंडक्टिविटी ज्यादा है. So that is why metal being is a good conductor of heat transfer. These are what? Non-metals, ice, glass, concrete and water. इनकी थर्मल कंडक्टिविटी देखो आप कितनी कम है ना. एंड हाइड्रोजन एंड एयर, दीज आर द गैसेस, इनकी तो नेग्लिजिबली कंसिडर कर सकते हैं. जैसे मेटल, नॉन मेटल्स एंड गैसेस. अब आप ये क्वेश्चन का आंसर इजीली दे सकते हो. व्हाई सम कुकिंग पॉट्स हैव कॉपर कोटिंग ऑन द बॉटम? So that copper can absorb maximum heat and heat can be evenly distributed. ठीक है ना, for cooking. अब ये क्वेश्चन देखो, ट्राई करो आप. इसमें क्या है? An iron bar which is L1 is equals to 0.2 meter, A1 is given, K1 is also given, L2 भी given है, A2 भी given है, K2 भी, are soldered to end, इस तरह से किया है. तो बताओ ये कौन सा कनेक्शन है? सीरीज है कि पैरेलल है? बताओ. Tell me everyone. Is this a series connection or parallel connection? Azmala, Devanand, Dimple, Farnas. Everyone. बताओ भाई. रायस्टार, सुहरा, शामी, फरनाज, शनमुख, देवानंद, एवरीवन. इज दिस अ सीरीज कनेक्शन और पैरेलल कनेक्शन? देखो एंड टू एंड कनेक्टेड है, इसका मतलब जो यहाँ से हीट ट्रांसफर आएगी वही सेम इसमें चले जाएगी. तो if the heat transfer rate is same, so we can say this connection is the series connection. So what we have to find out temperature of the junction at the two bars here, and the equivalent thermal conductivity of the compound bar, and the heat current through the compound bar. So it would be easy. Temperature of both the ends are given to you. Okay. Now L1 equals to L2 equals to L. A1 और A2 भी सम सेम गिवन है, बस K1 और K2 का डिफरेंस है. अब ये सीरीज कनेक्शन में है तो हीट ट्रांसफर रेट सेम होगा. यहाँ से हम कह सकते हैं कि हीट ट्रांसफर रेट इज सेम, मतलब H1 इज इक्वल टू H2. H1 को वी कैन राइट K1 A1 T1 माइनस टी नोट. कहाँ से कहाँ तक के लिए लगा रहे हैं? यहाँ से इस एंड से जंक्शन के एंड, इस एंड का टेम्परेचर इज 373, इस एंड का टेम्परेचर इज टी. तो T1 माइनस टी नोट इज इक्वल टू K2A2 टी नोट माइनस T2, यहाँ से यहाँ तक के लिए. ठीक है. L1 by L2. Now A1 and L1 or A2 and L2 will cancel out. It will remain like this. If you put down the value, this is the temperature of the junction when the bars are connected in a series connection. K1 T1 plus K2 T2 by K1 plus K2. Now, under the steady state, if we put down the values here, the rate of heat transfer will be K1 K2 upon K1 plus K2, A into T1 minus T2 upon L. This is written in place of what? R. So this will nothing but the resistance. ठीक है. So K देखो ये इक्विवेलेंट थर्मल कंडक्टिविटी क्या आई? 2K1 K2 by K1 plus K2. क्लियर? ये कैसे आया होगा देखो, मैंने बताया था कि सॉरी, आर इक्विवेलेंट सीरीज कनेक्शन है तो R1 प्लस R2. R1 क्या है? L1 अपॉन K1A1, L2 अपॉन K2A2. अब अगर मैं यहाँ से क्या क्या कॉमन ले सकता हूँ, L1 और K1, तो R इक्विवेलेंट भी क्या बनेगा? इक्विवेलेंट रोड की लेंथ विच इज 2 टाइम्स ऑफ L1 प्लस L2, 2L अपॉन K इक्विवेलेंट इनटू एरिया तो सेम है. अब देखो इस लेफ्ट साइड से आप L और A को कॉमन ले सकते हो, सो इट विल बी 1 अपॉन K1 प्लस 1 अपॉन K2. अब देखो L अपॉन A और L अपॉन A यहाँ से कैंसिल हो गया, तो यहाँ पे क्या बचा? 2 टाइम्स ऑफ K इक्विवेलेंट is equals to 1 upon K1 plus 1 upon K2. When you take the LCM, K equivalent will be coming out as 2K1 K2 upon K1 plus K2. This is it. ठीक है. So when you put down the values, you will get the values here. ठीक है, the numerical values. Now convection. What is convection? देखो in conduction, the material will not transfer, but the heat is getting transferred. ठीक है, and it probably true for the solids. But in convection, we transfer the heat by transferring the material. ठीक है. So convection is a mode of heat transfer where the actual motion of the matter is happening, and that actual motion of matter is causing the heat transfer. ठीक है. And it is only possible for the fluids, and fluid can be gases and liquid. So that particular mode of heat transfer is convection. It can be of two types, natural or forced. सो कन्वेक्शन एक ऐसा फिनोमिना है जिसके साथ हम डेली बेसिस पे डील करते हैं. ठीक है. सो नेचुरल कन्वेक्शन में ग्रेविटी प्लेज द इम्पोर्टेंट रोल. जैसे बॉइलिंग ऑफ वाटर है, तो बॉइलिंग ऑफ वाटर में क्या होता है, देखो यहाँ से पैन का जो कांटेक्ट है बर्नर के साथ है, तो यहाँ कंडक्शन से हीट ट्रांसफर हुआ. अब इस कंडक्शन की वजह से जो एडजेसेंट लेयर थी फ्लूइड की, जस्ट एडजेसेंट टू द पैन, बेस ऑफ द पैन, वो क्या होगा? वेपराइज हुआ होगा. वेपराइज होने की वजह से वो ऊपर की तरफ ट्रांसफर करेंगे बिकॉज दे हैव गेन मोर काइनेटिक एनर्जी, so they will be moving up. So if they were moving up, the new water will surface will come down, and then again this process will continue. ठीक है, दिस वन। सो यहाँ पे जो इसके एडजेसेंट लेयर ऑफ एयर है, वो क्या हो गई, वो द टेम्परेचर ऑफ दैट एयर बीन रिजन, टेम्परेचर एयर का बढ़ा तो काइनेटिक एनर्जी बढ़ी, तो इसलिए वो ऊपर की तरफ मूव करेगी। अगर वो ऊपर की तरफ मूव करेगी तो जो सराउंडिंग एयर है, ताकि वैक्यूम ना बने, इस स्पेस को फिल करेगी, फिर से वो गर्म होगी, ऊपर जाएगी, ये स्पेस को फिल करेगी, एंड दिस प्रोसेस विल कंटिन्यू टिल द हीट विल बर्निंग आउट। ठीक है। अब नेचुरल कन्वेक्शन से बहुत सारे फिनोमिना है, जैसे रात के समय पे जो सी एरिया है वहां से क्या कूल ब्रीज आती है, और दिन के समय में वार्म, तो इट इज बिकॉज ऑफ द नेचुरल कन्वेक्शन। बिकॉज क्या होता है, ड्यूरिंग द डे ग्राउंड हीट्स अप मोर क्विकली देन द लार्जर बॉडी विच इज वाटर, तो ग्राउंड जल्दी हीट अप हो जाएगी, विच मीन्स ग्राउंड के साथ जो एयर एसोसिएटेड है वो क्या होगी, वो हीट अप होगी, तो गर्म हो जाएगी जो गैसेस हैं जितनी भी। ठीक है। अब here the we have warm air, and in this area it is much lesser warm, which means we can say this is cold. But at night what will happen, ग्राउंड जितनी जल्दी हीट गेन कर रही थी दिन में, उतनी जल्दी हीट लॉस भी करेगी रात में, बिकॉज देर इज नो सनलाइट देन। तो उससे क्या होगा, अब यहाँ की जो एयर है वो ठंडा हो जाएगी, और कंपैरेटिवली जो सी की ऊपर जो एयर है वो क्या हो जाएगी, गर्म हो जाएगी। ठीक है। फोर्स कन्वेक्शन में we force the material to move to transfer the heat, ठीक है, by using the pump or some other physical phenomenon, जैसे ये। अब देखो यहाँ से ये हीटिंग एलिमेंट तो है चलो, लेकिन हमें तो वार्मर एयर चाहिए थी, तो हमने क्या किया, एक फैन डिप्लॉय किया यहाँ पे। ये फैन क्या कर रहा है, पीछे से कोल्ड एयर को सक कर रहा है, एंड दिस कोल्ड एयर इज पासिंग थ्रू दिस वार्म शीट, and it is getting warmer, so but this process is having some consumption of energy. This fan is forcing this air into this, it is not automatically going into, so that particular phenomena in which we force the air or we force any fluid to transfer the heat, that is unnatural convection, or we can say forced convection। जैसे आपने देखा होगा, जहां पे ब्रिक्स बनती है ना, ऐसे ऐसी चिमनीज होती है वहां, और चिमनी से ऐसे एयर पास करती है, तो ये जो चिमनी बनाने का जो कॉन्सेप्ट है, इट इज बेस्ड ऑन कन्वेक्शन, क्योंकि यहाँ से जो हीट है, गैसेस जो हैं वो हाइयर टेम्परेचर पे हैं, दे विल मूव अप, जैसे वो मूव अप करेंगी, तो जो सराउंडिंग वाली एयर है वो इस गैप को क्या करती रहेगी, फिल करती रहेगी, यहाँ पे भी एयर फ्लो कर रही है। ठीक है। तो इस फ्लो की वजह से, इस एयर फ्लो की वजह से यहाँ पे एक प्रेशर डिफरेंस आएगा, प्रेशर डिफरेंस आने की वजह से दिस एयर विल मूव अप। ठीक है ना। इवन जो हमारा ब्लड सर्कुलेटरी सिस्टम, ह्यूमन सर्कुलेटरी सिस्टम, दिस विल आल्सो बेस्ड ऑन द फोर्स्ड कन्वेक्शन। अब देखो हमारी शरीर जो हमारी जो बॉडी है, दैट विल बी कीप वार्मर बाय द ब्लड इनसाइड आवर बॉडी, एंड दैट ब्लड विल बी फोर्स्ड बाय द हार्ट। So heart is a pumping machine, so that in fact we are doing the, here what we are doing, we are forcing the blood into the blood vessels or the veins, है ना, and this process is forced by the heart. So heart basically the force that we are using to pump the blood or to move the blood in our body. ठीक है, so that we will keep warmer and get the oxygen. Similar way in automotive engines, the cooling system is also the based on convection. ठीक है। Now, so this part of the heat transfer we will be dealing in the next class, and the remaining concept of it. And what we will dealing in the next class, a lot of numerical solve. So be ready for it. If anyone has any kind of doubt till now, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care. I'm launching a poll. Please do response in that poll so that I can mark your attendance here. So Ajmala, Devananda, Dimple, Farnaz, Suhara, Reister, Shami, everyone, please do participate in that poll. And if anyone has any kind of doubt, you can ask. Otherwise, the class is being over.